Hello everyone. Today we will look at relational expressions and if statements. Every programming language has the ability to allow you to write programs or write code that let you compare quantities and then, depending upon the result of that comparison, do either one thing or another. So these are called conditionals, and they depend on relational operators. So these are the standard relational operators that you will find in all languages. The syntax for these will be different in different languages, but here is what the syntax looks like for Python. Now let's look at each one of these comparisons, or let's look at each one of these relational operators. So they're all in comments here. So you can compare two quantities for equality by using the double equals sign. So for example, if we have a value in A and a value in B, then the way to compare them is to use A with two equal signs and B. Now if A and B are equal, the result of this will be true. If A and B are different, the result will be false. So the outcome of all of these relational operators is the value true or the value false. And we'll actually look at that coming up after we go through each of these relational operators. Now the others are shown here from top to bottom. If you have the triangular brace pointing back towards the left, then that's a less than. So that's your typical mathematical symbol for less than. And for example, if you wanted to compare two quantities, you could write A less than B like that. We can also test for greater than using the right side triangular brace. And here's an example, A greater than B results in true or false. You know, if A is larger than B, then you get true. If otherwise, you get false. Now, you can combine the greater than, the less than with the equals, and you can do a composite test. Okay, so A less than or equal can be written like that. All right, so there can be no space between those. Those have to be consecutive. So you can compare less than or equal, or you compare greater than or equal by writing those two relational operators. And finally, you have not equals. Okay, so the exclamation point followed by an equal gives you the not equal test. So here you have 6 additional operators. And you're already familiar with the math operators, plus, minus, divide, multiply. So here are what we call relational operators. And here are some examples over here. Now, these are all comments. So let's give A and B some value, and then let's actually compare them and print out the result that we get. Okay, so we can pick anything that we want. So let's just take some common integer values. And let's set A equal to 3, and let's set B equal to 5. Then let's print out some comparisons. So let's look at a print statement. So we'll put that here, Control V, and I'm going to print out the following. Okay, we're going to print out a string, A equals B, comma, and then we'll actually compare them. Okay, we'll print out the result of the comparison A is equal to B. Now I've got this for all of those, so I'm just going to go ahead and paste the rest of them in here. And then we'll run the program and we'll look at the output that we get. So I'm going to print out for all of these cases, all of these relational operators, one example. So here I'm just printing out what we're comparing, how we're comparing it. And then after the comma, we'll actually have the comparison show up here. Now let's run this program and let's look at the output. Now let's bring over the output window and look at the result we get. So here in the first one, A is equal to B. When I actually compare A is equal to B, then the result that I get is false. So the outcome of these comparisons, it is literally the word true or the word false. All right, so that might be kind of unusual. We didn't see true or false anywhere, but the result of a comparison using the relational operators will give you the word true or the word false. Now, this is true in Python, it's true in C and C++ languages. You might get something else in other languages. You might get a 0 or a 1 or something like that, but what do we care? We're working on Python, aren't we? So this is what you get with Python. So here you see then the actual comparisons of using the relational operators with the value A3 and B5. Now, these relational expressions can be used with what we now call a if statement. So we can include these comparisons with an if statement, and we can make our program choose to do one thing or a different thing. It all depends on the result of this outcome. So now let's look at some examples of these if statements. So to keep up with what we're doing, I'm going to paste in some comments here, or a comment. So we'll have some if statements, and then I'm going to print to the screen just here's some example if statements. And remember, the \n makes us go to a new line, so this will just skip some space between what we're doing next and what we just did up here with this code. Okay, then, let's put in some if statements. So here's the first one. So I'm going to just paste it right down below. And here is the syntax. Now, you've seen the loops that we've done so far. You've seen the for loop, and you've also seen the definition of functions. So you're probably getting accustomed to the syntax Python uses. So with an if statement, it's kind of structured the same way. Okay, we see that there's a colon over here on this side, and down below you'll see we have an indentation. The beginning part of an if statement is the word if. So that's one reason it's called an if statement. Then following the if, we have a comparison of some kind. So here, this if statement is saying if A is equal to B, then we want to print A is equal to B, and we'll print out the actual numbers A and B. So that's the way an if statement is structured. And you can have as many lines as you want below the if A equals B line, as long as the indentation is the same. All the statements will belong to the same if statement, in the same way that all the statements belong to a loop or a function definition if they're indented equivalently or equally. So what's this going to do? Well, if A is equal to B, then we will print out A is equal to B. Okay, what if A is not equal to B? Well, we don't get anything. So now the program is going to have a choice. As long as this is true, okay, if that condition is true, then we execute the code that's inside the if statement. If this is false, we do not execute the code in the statement. This program has A3 and B5. So that means that A equals B will be false, so we will not see this output. So let's run the program to prove that. I'll bring over the output, and we still show the result from the previous run, but look at the bottom. Okay, we have the print statement. Here's some example if statements, but there's nothing else printed down here. There's just some blank lines in there. So the reason we don't have anything else printed out is because this if statement was false. Okay, A is not equal to B, so we skip over that line. So now we have the ability to tell our program to make a decision based on a result of some comparison. Let's add some additional if statements here, and using the other operators, and we'll see what we get then. Okay, so I'm just going to paste those in right here, and we'll look at some of the other relational operators. So let's get some space here so we can see it better. So now I'm going to compare A is equal to B. That one was already there. So I'm going to add this. Okay, if A is greater than B, then I'll print out that statement. If A is less than B, then we print out this statement. Now notice that not all of these things can be true. Okay, if A is equal to B, if that happens to be true, we would print out that statement, A is equal to B. But if A is equal to B, then this one will be false. A can't be greater than B and also be equal to it. So this one will be false, that one will be false. In our case, we know that A is 3 and B is 5, so we can predict that this is the only one that will be true. So we should see A is less than B printed to the screen, but we will not get A is greater than B printed to the screen. Neither will we get A is equal to B printed to the screen. The if statement has to be true in order for the line below it to execute. So now let's run the program and look at the output. I'll bring over the output window, and now you can see that in the bottom part of this we have the example if statements printed again, we have 3 is less than 5. So the only line that produced any output is the one here. Okay, A is less than B. That was true, so we did print out 3 is less than 5. Okay, so we saw that. But we didn't get anything from these other if statements. Okay, A is equal to B, so that's false, so we did not print A is equal to B. Okay, 3 greater than 5, that's false, so we don't print out A is greater than B. We only print out the line after the if statement that's true, so we get 3 is less than 5. Now, let's add some more if statements that use the other relational operators and then look at the output. So we can put the other statements down here. And now I'm using the other 3 relational operators, greater than or equal to, less than or equal to, or not equal to. Now again, let's anticipate what will be printed to the screen. A is 3 and B is 5. Okay, so this one greater than or equal, that will be false. 3 is not greater than or equal to 5. But this one is. Okay, A 3 is less than or equal to 5. Okay, so this one will be true. So here we have the combined or compound expression or compound relational operator, less than or equal. So as long as either one of those is true, then the whole thing is true. And then finally, we know that A is not equal to B. 3 is not equal to 5, so we would expect that to be output. All right, now going over this again, what do we expect? All right, so A equals B, false. A greater than B, false. A less than B, that's true, so we should see this line output. Then A greater than or equal to B, that's false. A less than or equal to B, true, so we'd expect that one. A not equal to B, we would expect that one. So out of these 6 if statements, only 3 of them will be true, so we will only see 3 lines output to the screen. So now let's look at that. So I'll bring over the output window again, and we can see the output that we get. So we did get 3 things printed to the screen. 3 is less than 5. Okay, so that's the result of this one. If A is less than B, okay, that's true, so we print out A is less than 5. We have 3 is less than or equal to 5. Well, that came from the next to the last one here. Okay, A is 3, B is 5, less than or equal is true, so we print out A is less than or equal to 5. And finally, the bottom one, 3 is not 5, so we have A is not equal to B, so we print out 3 is not equal to 5. So you can see how these if statements work then. As long as the relational expression evaluates to true, then we execute the code that belongs with that if statement. If this is false, we skip over that code entirely. We just don't do it at all. All right, now let's look at some more examples. So I'm going to put another comment here. So these are some examples that came out of our textbook. So I'm going to write that to the screen, and again, I'm going to skip a couple of lines just to space between the different sets of examples that I'm doing. Okay, so now let's look at some of those examples. All right, so here we have this one, so I'll copy and paste it over. So here we have a variable called expression underscore level. We set it equal to 125. Now, one thing I should point out here is this double equal that you need to use when you're comparing two things. That can be very error prone because we're just not accustomed to typing in 2 equal signs. So when you're comparing two things to see if they are equal, then you use 2 equal signs. If you're just using an assignment statement, in this case to set the expression level to 125, then that's 1 equal sign. Now, the if statement is this: if expression level is greater than 100, don't forget the colon, then we'll print this out. So if the expression level is anything that's less than 100, then this would be false. Anything greater than 100, it'll be true. So in this case, it's true, so we do print out that statement. The gene is highly expressive. Okay, now, before we run that, because that one's pretty obvious, let's put another example in here. This one is a little bit more useful. Then let's use a list. All right, so let's say we have this list, ACCS equals, and then we have these things that are in the list. Then we can use a for loop to go through all the items in the list, and then we can use an if statement to interrogate each one of those items. So here is what we can do. We want to use this variable, and here's the for loop again. So for this variable, for accession in ACCS, that just cycles through. Okay, you know, it starts with the first one, goes on to the next one, all the way to the end. That's what the for loop does. Now, inside the for loop, we're going to test each one of those items, and we're going to see if it starts with an A. Okay, now this is something that hasn't been introduced yet. Okay, the starts with function or method, that hasn't been introduced in so far, but it's one that's available, and we'll just go ahead and use that one. The other thing we could do is we could use the square brackets and use index 0 there. All right, and then we could use another test. At any rate, we'll go with what they gave us, right? So if this is true, then we will print out the value. All right, now in this case, notice that there isn't a greater than, a less than, or an equal at all. Okay, it's just this statement. So it's possible for you to write if statements that do not involve the relational expressions. So in this case, we're using the starts with, and if it starts with an A, we get the value true back. Okay, so that's how that works. If it comes back as any other letter, like up here there's a B that shows up and there's an H, so any other letter is going to give us false. Okay, so this starts with function, and I call it a function, but it's really a method because we have a dot over there. So this is going to evaluate the first letter in each one of the things that's in the list, and if it's an A, we get true. If it's anything else, we get false. So as long as this is true, then we will print out the accession value okay, I'm going to print out the string. Let's put another C in there because I didn't type it in. So we'll print this out, and then we'll print out the actual value, which is one of the elements of the list ACCS. Okay, now let's run the program, and let's get the output from these two examples. So I'll bring over the output, and down at the bottom, we have the output from our latest examples. Okay, so here we have skipped a couple of lines. Okay, so that came from the print statement over there. We print out textbook examples, and then we have the first if statement. So here is an if statement using the greater than sign. So that's true. So we print out this print statement, Gene is highly expressive. Then we move down and we have the list, ACCS, and we're going to go through that. And we're going to look for all of the elements in the list that begin with the letter A. Okay, so we have one here, here's one there, and here's the next to last one. So we have 3 of them. So for all of these elements that begin with the letter A, then we'll print that out, and here you see the outputs. Okay, AB56, AY93, and AP97. So by combining a loop that goes through a list of things, or it could go through elements in a file, it could go through a lot of things, then we can combine that loop with an if statement, and we can extract information from lists or files, and then we can do whatever we need to do with that data. Now, I want to include a couple of more examples here with lists, so now let's go look at those. I'll put another comment here. So we're going to print out states that start with the letter N, and here are some more examples. All right. So I want to use some of the lists that you've seen in previous videos, so I'm just going to go get some of those lists, and I'm going to copy from my notes, and I'll paste that in here. Okay, so here's a list of states. Here's a list of zip codes. I'm not going to use zip codes. Let's take that out. Okay, so I've got a list of, I didn't take it out, did I? Okay, let's try to see if I can edit here. Okay, highlight that and back it up. Okay, now we're good. So I've got a list of states. I've got a list of high temperatures. So the states, you can see them listed here. All right, and then here are just some real numbers that constitute the items in the list high temperatures. Now let's work with those a little bit. What I want to do is to print out the states that start with the letter N. So I need to have a way to go through this list of states and I need to have a way to test to see the letters, the states that begin with the letter N. Okay, so I could use the same kind of thing up here using the starts with function, but I'm not. I'm going to do it a little bit differently. So let's look at the for loop we need for that and the if statement. So let's paste that in. So you've seen already in our loops, and with the for loop, we just pick a new variable state that's not the same thing as we have in the list. It has to be a different name. We have the colon after it. So you know that this is going to loop through every state in the list states. Then we can interrogate the item that's stored in state, and each item that's stored in the state is going to be the state, North Carolina all the way up through New York. So we're going to look at the first letter, and here's the other way that you can look at that. All right, so we did the starts with up there. You can also do it like this. Okay, so if state index 0, that gives you the first letter. If it's equal to an N, then we want to print out that state. If the first letter is anything other than an N, this will be false, so we will not print out that state. Now, let's run the program, and let's look at how we can process that list. So now we have the output. Let's put that on screen. And at the bottom, you'll see the result of that loop. So here we have the more examples. And let's put it up there so we can see it better. So then we go through the for loop. For state in states, if state 0 is equal to N, we'll print out the state. So we see the states North Carolina, we see Nevada, and we see New York. So it only pulls out the states that match our if statement where the first letter is equal to N. So now we have a very powerful set of tools we can use. Okay, we can go through a list, and then we can interrogate the items of the list, and then we can process them in some fashion. So for now, we're just printing them out. Now let's do one more example in this video, and I'm going to use the high temperatures. We'll use that list for this one. So I want to print out the temperatures that are above 90 degrees. So let's put a loop here that'll do that. All right. So I've got a comment. Print the temperatures that are above 90 degrees. So here I'm going to use the greater than. If I wanted to include the number 90, I could do a greater than or equal to. So this is only going to print out temperatures that are 90.1 or above. If I've got just a plain old 90 in there, it's going to skip over it. So here we have the for loop again for temp in high temperatures. So that just means, we start with the first temperature and we go one by one till we get the last one, which is 100.2. Our if statement is going to test each temperature. If it's greater than 90, then we'll print that temperature out. If it's anything less than that, we will not. So we will not print out the 88.9, we won't print out 87.8, and we won't output the 89.7. So we'll only print out the temperatures that are 90, above 90. All right, so now let's run the program and look at. So now we have the output, so let's bring that up on screen. And here is the output we get from that last loop. So here you see we get the numbers 91.5, 92.1, 99, 93.6, and 100.2. So we did not get the lower temperatures that are below 90 printed out. So here's just another example, and in this case, we're using the greater than sign, whereas we used equal up here. So you can employ any of these relational operators that are available to you. So you can test for these, in 6 different ways that you can use. So by including then these relational expressions with loops, then you can do quite a bit of work with a small amount of code. So this is our first introduction at conditionals. So you have seen the 6 relational operators, and you've seen the introduction to these simple if statements. Okay, so we are going to stop here. There will be additional things that are involved with if statements coming up in future videos, but this gets the introduction completed. So now you've seen the relational operators, and you've seen some simple if statements, and you've seen a few examples of how to use them. So I think now is a good time to close this video. So we'll stop here.